Hi, in this tutorial I'm going to go through the steps involved in creating some sample lines, cross sections and computations of material volumes. So with this particular starting file I've already created an assembly over here. I've created an alignment and the alignment has been profiled for both existing ground level and a vertical design. Very basic alignment, it's a straight line, there's nothing complicated about it, and I've created a corridor using the assembly. So what we can see in here is a plan view of the corridor. Now, first thing I need to do to create some sample lines, cross sections, and to compute some materials for volumes is to create sample lines. Now, my screen may look slightly different to yours depending on which version of Civil3D that you're using, but up here you will find a button for sample lines on your home tab or on your home ribbon. Okay, so click on sample lines. Now it's saying to me down here, select an alignment or press the enter key to select from a list. Sometimes I find it difficult to actually click on an alignment down here because there are overlapping lines. So what I'm going to do is press the enter key, and popped up on a different part of my monitor. Over here now I have a list of all the alignments in my drawing. There's only one and the alignment is called New Road, so I'm going to go OK to that. And now what I have is the sample line group dialog box. So I'm going to just double check all of this. So it's going to be called sample line collection number 1. Sample line, road sample, section name, all of those things are going to be pretty much acceptable as the default settings. And the data sources are going to be, there's going to be two of them. There's going to be the survey, which is the surface, the existing ground surface, and there's going to be the corridor, which is the feature lines that make up the corridor. So I'm going to go OK to that. I don't need to change anything. And now I have a toolbar up here for creating the sample lines themselves. So there's a couple of different ways of doing this. You can manually select where you want the sample lines to go, or you can speed things up a little bit by going to this drop down menu here, and we're going to go by range of stations. Now there are two things you need to look at here essentially. First one is how often do you want your sample lines, and it's defaulting here to 20 meters on straight lines and 20 meters along curves and spirals. It's going to vary from job to job, but just to keep it small at this point, I'm going to put in a 50-meter interval in all cases, and I'm also going to make sure that I'm getting a sample line at the start of my alignment and at the end of my alignment by changing the start and end both to true. That's the first thing. The second thing you need to do is think about the width of the sample line itself. How far to the left and how far to the right of the center line do you need to go? Now this is going to vary depending on the job you're working on. What I've done is I've gone in here and I've had a look at my map, and looking at this point here, which is kind of the outer edge of the embankment or of the cutting, the widest part of my road is just under 80 meters wide from the bottom of the bank to the bottom of the bank on the other side. So what I'm going to do is I'm going to use a width of 40 meters to the right, to the left of the center line, and also 40 meters to the right of the center line. You may get away with a bit less there, you may need more there, it depends on the geometry of the road, but 40 will work for this particular instance. And I'm going to go OK to that, and I'm going to zoom out now, and you can see those sample lines have now appeared on the drawing. I can close this toolbar down, and the next step is to create some cross sections. So as you can see here, just a quick reminder, what I have here is my longitudinal section profile. I've got a assembly just down here, and I've got my road alignment and corridor and sample lines down here. So I'm just showing you I don't have anything out here at the moment, and that's where I'm going to put my cross sections. So to get this to work, what you need to do is just click on any of the sample lines at all. Doesn't make any difference which one you pick. And up here then you will see an option to create section views, but we don't want to select just one, we want to create multiple section views. So that's what we're going to do. We're going to click on create multiple section views. Now this brings up a dialog box where we can look at different settings and different parameters of the views like this. So again, like a lot of things, most of the time you can just kind of click next with these because the defaults are going to be okay. What I'm going to do is the road alignment is correct, the sample line group is correct. Those numbers look good. My alignment is about 2,700 meters long. I'm going to just go next for this one for the moment. And yeah, so what I'm going to do here is change the placement options to draft, which will allow me just to put them up there for working. I'm not really going to be printing these out just yet. So I'm going to put them in as draft. And the plot style will be basic, and I'm just going to change a setting in here. What I'm going to do is I'm going to set up my plot style using the array option, and I'm going to plot them out using by rows, starting in the upper left hand corner. So as we move up through the changes, I'm going to be going from the upper left across, then next row down horizontally, next row down horizontally, and so on. So it's just kind of a little bit more in control of how these are going to appear on the screen. So I'm going to go and apply that. Okay. I'm going to go next. Again, these have been picked up from the left and right distances from before, so I don't need to change any of those. The elevations will vary. Obviously, not every cross section will be exactly the same, so that's fine. Next. Now the labels, what do you want to put on these? I'm going to go with no labels for the moment, just to keep it clean, but later on you can actually change the profile views and you can put in various different bands for labels, so I'm not too worried about how that's going to look right now. I might change my corridor. No, I won't. I'll leave that as basic as well. So again, I'm just going to go next, and my data bands, again, offsets only, fine, it's no big deal. I'm really only creating these cross sections now to allow myself to allow the computer to be able to do the quantity takeoffs. So how they appear and how I may want to show them later on, I can change them if there's a difference between what I'm going to get now and what I might want to show later. So I'm going to go create section views. Identify section view origin. Now, because we told the computer to array them based on the upper left hand corner, where I click on the screen now will become the upper left hand corner of the little array. So I'm going to click on that, and you can see that they've appeared on there now. So they're quite a basic view. All you're going to see really is the chainage label up at the top, but you get to see the embankments in here, and you get to see the assembly in here, along with the existing ground level just across here. So it's pretty quick to generate those. So that's created the cross sections. Next thing we're going to do is we're going to build the corridor surfaces. Right now I've got a corridor, but I don't have corridor surfaces, so I'm just going to tap escape there a couple of times just to come out of the section views. And I'm going to create a corridor surface by clicking on the corridor, and up here I've got an option for corridor surfaces. Now I'm going to build two corridor surfaces. I'm going to build one for the very top of the paving, and I'm also going to build one for the formation level. You'll see why in a few moments. So I'm going to create a surface over here, and the data type will be links. I'm going to go with top. Just realize this box, this window doesn't fit inside my screen casting software, so I'll just resize it like that, and I'm going to add that surface down here. Now I'm going to rename this surface up here, and I'm going to call it top surface. The surface style, I'll just go with contours 1 and 5, adding in this one as a break line, and the overhang correction will be to the top links. So now I'm going to create another surface over here, another new one, and I'm going to rename this one straight away. I'm going to rename this one formation. Oops, double click in here and formation. You may never really want to see these surfaces, so showing them by contours and showing them by surface banding and things may be redundant later on, but we'll see how we get on. Now this time I'm going to put in the formation as the code. Okay, and I'm going to add that in as a break line, and I'm going to set the overhang correction to the bottom links. So in other words, the surface will be going to the bottom of my assembly and to the bottom of the sub-assembly parts. Okay, so I've created two surfaces in there, renamed them. One's called top, one's called formation. The top one is based off the top of the assembly. The formation is based off the formation levels of the assembly, which comes from this drop-down list over here. And checking the overhang corrections to the top for the top and for bottom to formation. Okay, so that's those two corridor surfaces. It's asking me to rebuild the corridor. That's fine. And you should see these appearing as contours in here now. Okay, so we've got contours in there, and it's all working inside the boundary, which is fine. Okay, so that's the corridor surfaces made. The next thing we need to do is to add those surfaces to the cross-section details. Okay, so I'm just going to look in here. You can pick any of these cross-sections, it doesn't matter. I'm going to pick on any of these, and I'm going to click on the view itself, like that. Now, not sure why this happens, but you can see here my ribbon is blank. So if that happens, I'm just going to tap the escape key a couple of times and click on the view again, and this time the ribbon looks the way it should look. Sometimes it does that little kind of a stutter like that where the ribbon doesn't populate for some reason. Just on this command I've noticed it. So we need to add those two new corridor surfaces into the cross section. So we clicked on it, and what we're going to do is click on the sample more sources button, and it's saying select sample line, section, view or section. So again we click on the sample view like that, cross section view. So in here now we've got the two surfaces that we made in the last step. So I'm going to click on the first one, add it in. I'm going to click on the second one and add that in. Now I'm just going to widen these out a little bit so you can see corridor 1 top surface, corridor 1 formation. So they're the surfaces that we made in the previous step. So the top surface, I'm going to change the surface style to finished, and for the formation I'm going to use the existing ground. Now depending on your installation of Civil3D, you may see more surface styles in here. I'm getting very basic ones with the installation that I've got, but I know that on some installations of Civil3D you could get a lot of different styles in that list. So I've only got two to choose from, so I'm using the finished ground style for my top surface and the existing ground style for the formation level. So I'm going to go OK to that. Now it's kind of subtle, but if you go back in and look at your cross-section views now, you will have those two surfaces showing up in there. So let me see if I can just show that to you. If I hover in about here, you can see now that what's highlighting on my screen is a new surface that's coming down the slope, going underneath the footpath, going down underneath the curb line, and all the way across underneath the bottom of the assembly. And you can see on the pop-out menu that the name of that now is a surface that's based on the corridor formation. If I hover over the top, I get the same thing here. I've got the name of that there now is coming up as corridor top surface. So those two surfaces are now in my cross sections. Okay, next thing we need to do is to compute some materials. So again, to do this, you can click on a profile view if you don't have one already selected, but because I've got one already selected, I'm getting the proper menu across here. I'm going to hit escape there and just come out of it just in case you've done that as well, just to show you again how you can go back in. So click on any surface, any section view, and you should see the ribbon now looks like this. And what we're going to do is we're going to go to the compute materials button up here. So again, it's asking us which road and which sample line group we want to use. I've only got one of each in this drawing, so it has to be those two. I'm going to go OK to that. So on this one now, we're going to go to look at our takeoff criteria, and we're going to set it to earthworks. We're really just interested in the cut and fill for the earthworks themselves, the main bulk of the work. Okay, so our existing ground and our datum. So our existing ground surface will be the surveyed data, the surface that was created from the survey. Sometimes that might be called EGL, but it's the name of the surface representing the existing ground. And the datum, which is the thing we're interested in, will be the formation, the surface called formation level. Because when you're thinking about cut and fill, you're going to be going from an existing ground to a formation level really, and your road will be built on top of that formation level then. So we'll put those two in there for those. We can go OK to that now. The computer will be working away in the background again for a second there. And then what we do is we go back into compute materials. Oh, I suppose before I do that, maybe just have a look at what's happening to the cross section. You can see here now we've got an area that's shaded in here, which is in cut because our existing ground is coming across here. Let's see if we can find one that's in fill, maybe down here. Yeah, so you can see we've got an area now that's shaded in there, which will be fill, and that's going to, if I highlight this for a second, you can see that that's going to underneath the assembly. So we'll go into compute materials again and go OK. And now we're into our material list. So here what we're going to do is actually get some figures out. Everything up until now has just been setting up towards this really. So what we're going to do is we're going to change the name of this material list over here to quantities, like that. And we're going to click down here to create a new one. And we're going to rename this one here to say cut. Okay, so what we're going to do is we're going to work off the base and comparison surfaces, which should automatically have been picked up because we did it in the previous step, where the base surface is called survey and the comparison surface is corridor 1 formation. We need to change the quantity that we're actually looking at here, that we want to, that we're interested in, to cut as well. And we're going to change the shape code to cut as well. Now, this is the next thing you need to be a little bit kind of mindful of, this above and below. Now, when we're thinking about cut, what we're really thinking about is we're thinking about all the material that's below the existing surface and above the corridor formation. So we need to just make sure these below and above are correct. Okay, we now need to go into add a new material. We're going to change this material name to fill. And again, we're going to add in our survey surface, and we're going to add in our formation surface. Those were already brought in at the start of this step, but we have to manually bring them back in here using the plus at this stage. This time our quantity type is going to be fill, our shape code or our shape style is going to be fill material. And again, we need to think about our above and our below. Well, really, if we're dealing with something, when we're talking about fill, we're talking about material that's above the existing ground but below the formation level. So it's the opposite of what we had up here. Okay, so that will give us a volume report for the cut and the fill, but we can add in another step here as well, which sometimes might be useful, where we can look at the individual components of the assembly itself. So for example, if you wanted to find out what the volume of wearing course might be, let's have a look at how we can do that. So we need to add a new material. This time the material is going to be not surface but corridor shape. and it's going to be based on the pave 1, which is the uppermost layer, and we're going to add that in there. Okay, so I'm getting a message here that says the corridor shape can be added to structure type materials only. So I'm going to go OK to that, show you how to fix that. It's in the quantity type column here. This should say structures. And I can rename this material just while I'm over here, and I'm going to call this wearing course. And this says corridor shape, this says pave 1 and add, and it appears down here now. So the shape code for that one we can leave as no display or no shading, because the wearing course is already has a hatch pattern on the cross sections, so we don't need to show it down here as well. Okay, so we created 3 different materials there: our cut, our fill, and our wearing course, and we go OK. Again, give the computer a couple of seconds to catch up. What you'll notice straight away is that the hatch pattern for fill now looks like this, where it was a kind of a solid white color a few moments ago. And if we look at the one for cut, it has kind of a red hatch in there now as well. Okay, we're almost there. The next thing to do is to create a volume report. So again, I'm going to hit the escape key just to come out of it, just in case you have hit the escape key. And to get back in here now, you click on any section view at all, and over here you'll see generate volume report. So we click on that. Now, depending on where you are in the world, these formats are slightly different, but the one we're going to be using is the one that's based on the UK and Ireland standards. So we want to check that we've got the right one in here. So we open up a folder. You should find a UK and IE folder in there, and we're looking for the one called Select Material. So double click on that and go OK. Now it'll ask if we want to run a script, and that is OK. We want to run that script, and it's going to put it out in this kind of a format here, where we've got each chainage. Now you can see it's going from 0 to 50 to 100. Because I told it to use a 50-meter interval for the sample lines. You could have more. You could have chainage 0, chainage 10, chainage 20. It depends on the circumstance and the contracts. I suppose the main one you're really looking at here is the cumulative volumes over here, and they will add up as you go through. So let's go down to the very end here, and we find that by the time we get to the end of the road, we've had 444,000 cubic meters of cut. We've got almost 40,000 cubic meters of fill, so there's a fair old imbalance there. That may prompt us to go back and look at our vertical alignment design levels again. And we've got also a report on the wearing course, that by the time we get to the end of the road, that wearing course has 487 cubic meters in its volume. So it's not just about the cut and fill based on existing surfaces. It's the comparing existing surfaces to a dig level, but it's also looking at the design of the assembly and calculating that for you as well. So that table can be exported into Excel. You can kind of select all like this with holding down the right mouse button, or you can capture it, doing a screen capture, and put it into a report. Okay, so that's the volume output. And the very last thing is to look at the mass haul diagram. So I'm just going to click on mass haul diagram over here. And again, most of these things are going to be absolutely fine the way that they appear. Free haul distance, well, again, this is going to depend on what the contract is, but let's just say 500 there. Create diagram, and click anywhere to place it. Okay, so we've got our mass haul diagram here generated pretty much automatically, and certainly a lot quicker than you could do by hand. Okay, so it's a quick run through on setting up the sample lines to create cross sections, building corridor surfaces, adding the surfaces to the cross sections, computing materials to look at cut, to look at fill and to look at the material of the actual assembly itself, the wearing course in this example, and then outputting a volume report and outputting a mass haul diagram.